folks, thank you very much for that. And ladies and gentlemen, we now move to panel 2, titled Disruptive Technologies for Emerging Challenges. And leading us in this panel is Prith Roy. Prith has recently moved from Yarra Valley Water to Southeast Water, where he uses his expertise in maintenance, reliability and asset management. Prith is also the IWN Deputy Program Manager for Asset Management and Optimisation. Ladies and gentlemen, please welcome Prith to lead the panel. Thanks, Prith.
Good morning. Good morning, everyone. That was an amazing presentation, so thank you again. I'll have to chat to you after this. But now today we've got a really amazing panel. I think it's the life cycle of everything we do. We've got someone from asset management, someone from research, and someone from policy. So yeah, exciting stuff. Topic today is disruptive technologies for emerging challenges. We'll call upon Callum Tate first. He's from TasWater. He's the operational support engineer. And in IWN, I should have said, by the way, we wear multiple caps here today. So for IWN, he is the program manager for asset management and optimization. Please give a big hand for Callum. And yeah, I guess something to keep in mind while we're hearing about Callum is positive disruption. Yes, take it away, Callum.
G'day, everyone. So I'll be talking about how asset management fits into all the stuff we've been talking about today, and just listening to the presentations this morning, there's a lot that overlaps. And I think, like, not having talked to anyone about what the presentations were beforehand, I think that's really positive that we're all heading in the same direction. We've got another.
Oh, sorry. Yeah.
So just a bit of an update on the program and where we're at the moment. So to start with, I think the thing we're trying to push at the moment through.
You want to stand here?
Yeah, that's not a bad idea. Prith's done a heap of work on this already, the asset maintenance community. So really we kind of seen a big hole in linking between utilities and getting people who are doing asset management to work together and use the best methods that are out there. In my short time in the water industry, I've seen a lot of not necessarily not well thought out, but not well done asset management, simply because we don't know what the best way to do it is. And there's a lot of fumbling around. I think we can learn a lot from each other by pooling resources and talking with each other. So a couple of the more more focused projects we've been working on. So one that recently wrapped up was a lagoon leak detection trials. This is focusing more on, I guess, how we do asset management with less disruption to the asset performance and use, and finding more or less intrusive ways of getting information on our assets so we can repair them with minimal cost involved. So that was looking at finding leaks using applied electric currents to both clay lined and plastic lined lagoons. So that wrapped up with some pretty good results last year. And then we're starting one down Tassie, looking at a coagulant dose control system that looks at raw water quality coming into a water plant and adjusting coagulant dose without the operator's input. The idea there is the operator can spend more time looking at operating the rest of the plant, making sure it's operating correctly, rather than having to stand there doing jar tests all day and figuring out what the coagulant dose is. I think the big challenge we have in asset management at the moment is maintaining our ageing infrastructure. We're getting to the point now where we've had water corps in place for a long time now, and all the pipes are getting older. Everything we've built is getting older, so we've got to maintain all these assets. then the problem is we've got all these assets, but we've only got a finite amount of resources to maintain them. So we've got to figure out what to prioritise and when to do it, and what's the best time to do that. We heard a bit of talk earlier about using machine learning to identify which parts of pipes to replace and when to do that, rather than just saying, oh, this normally lasts for 20 years, we replace this after 20 years. If we can figure out the parts of our networks that need replacing at the right times, we can minimise the costs we need to spend there, and we can replace and repair more assets and maximising the utility we get from our investments there. Another thing that was mentioned earlier was going from reactive to proactive maintenance. I know in Tassie we still do a fair bit of reactive maintenance, and working with operations, it's something they spend a lot of their time doing. And if they can spend less time doing that, they can spend more time on doing maintenance on stuff before it breaks, which is less disruption to our customers. But in the long run, it also means our assets last for longer, and we don't have to spend more money than we need to. And that links into the utilising our investment the best we can. So a few of the trials that the Asset Management Optimisation Group have been doing recently and have finished link into this quite well. So we've got Modeler. So we ran that last year. It's a program of work solver that uses machine learning to figure out how we should maintain our assets. So predicting what to maintain and when to do it. So that's really important in making sure we're not overspending and we're not underspending. So we're finding where we need to target our investments. The MAD-E, I can't remember what the acronym stands for, but it's modelling reliability of instrumentation and the like to ensure that we're performing maintenance right when we need to prevent failure, which leads to downtime, and we're doing full replacement rather than maintaining and keeping the same one in service for longer. The LIS, so the liquid integrity systems, that's the lagoon leak detecting stuff I talked about earlier. That allows us to keep lagoons online while we're checking for leaks, and we can target them. Maybe we know exactly where it's leaking. Maybe we don't need to do it straight away. We can time stuff better. And then Compass, again, we're looking at using stuff that can minimise the knob adjusting that was talked about earlier. We don't have to go and keep changing our process all the time. We can get something to focus on parts of that, so we can look at the more of the maintenance side of it as well. So a bit of the impact that this will have, we'll have to have a lot more reliance on asset monitoring devices and modelling of our asset management. So we don't have to spend as much time just looking at it in person or go on and have a look at this asset. Oh, does it look like it's about to fail? We can kind of predict this with a bit less investment in time. I've talked about it a lot already, but maintenance before failures is really key. As long as it take up operator time, it takes up the money that we need to invest in the newer stuff. And as standards improve, we've got to improve our stuff anyway. So having to spend money on replacing all this stuff all the time really bogs down everyone. And once again, the reduction in service and operational disruptions. So not only on the customer side and on the operational side, we want to minimise disruptions where we can. I think that's me done.
Thanks, Callum. Yep. Grab a seat. Yep. Anywhere you want. I feel like there's a lot of references to AI, I think, and machine learning and predictive maintenance. It's happening. Cool. Thank you. And we've got next on our panel is another star, Aravind Surapaneni. He's from Southeast Water. Currently is one of the principal scientists at Southeast Water. And for IWN, when he wears that cap, he is the program manager for IWN's Biosolids and Resource Recovery Program, as well as the deputy director for the industry for the Australian Research Council, ARC, training center for the transformation of Australia's biosolids resource.
That's a mouthful, isn't it?
That is a mouthful and a lot of caps for you. So I'll hand it over to you.
Hi, everybody. So this program is all about biosolids and resource recovery. I'm also, my deputy program manager is Rodrigo from Goulburn Valley Water. Unfortunately, he couldn't make it today. So this program supports and promotes early stage development of emerging technologies. And so there are currently 6 projects on the go. Again, we are a part of Biosolids Training Center. We are also part of this CRC CARE project on emerging contaminants. And we are also a DEECA funded project on converting biosolids to biochar through functionalized pyrolysis concept. Prith Systems is funding, is doing a project on with Northeast Water and co-funded by IWN on converting biosolids to biochar. And we have currently 2 new projects that will start in the next financial year. The University of Newcastle ARC linkage project on biosolids in PFAS and biosolids, especially dealing with short chain emerging short chain PFAS compounds. And recently we've also got $1 million project with Soil CRC trying to assess the beneficial use of biochar in farming systems, agriculture. Not to mention the biosolids, biochar to batteries project from Deakin, part of SV funding, isn't it? That's right. So the challenges of biosolids, management of biosolids is an ongoing problem. We have tighter regulations, especially on PFAS, and that is creating as issues with finding suitable agricultural land, or finding we need more land, more agricultural land to spread biosolids. That will cost us more. We need to apply biosolids at a lower application rates. And there is a commitment from water corps to meet net zero emissions, or and also to circular economy commitments. And more importantly, there are some technological gaps. There's a gap in the understanding what technologies are required to tackle contaminants of emerging concern. So one way to solve some of the challenges are through, we suitably opted for one route, the biosolids to biochar route. It's not only across Australia, but Europe, Canada, EU, and UK. They're all looking at the same option, trying to convert biosolids to biochar as a plan B option for managing biosolids. And in 2021, we conducted one pyrolysis experiment trials at Melton. We're calling it a Pyroco Mark 1. Most of you might have seen the video last year. And currently under a DEECA funded project, we're building Pyroco Mark 2. And we're going to run that trial in August 2023. Prith Systems will do a similar trial with Northeast Biosolids sometime in the next financial year, anytime after July. So we're trying to kill 2 birds in one shot. By pyrolysis, we will convert biosolids to biochar. The biosolids biochar will be always high in heavy metals, but low in carbon, because we're not dealing with the biomass as a feedstock. So one way to solve that problem is to co-pyrolyze biosolids with organic biomasses like a FOGO or any other organic waste, canola straw, loosened pellets, if you want, loosened straw. So mixing biomasses with high in carbon, low in heavy metals with biosolids, which is high in heavy metals, will create through different any technology, any thermal technology. Here we're using a Pyroco, is a Victorian invented technology to create a functional biochar. So I'm saying killing two birds with one shot. Okay, the impact. Again, it will this technology will destroy contaminants or emerging contaminants, not only PFAS, but also microplastics and endocrine disruptors. And again, overall, it provides a plan B option for biosolids management, and plan A option being beneficial use of biosolids in agriculture. So you should always look for plan B, plan C options for any system you develop. And also, it provides a circular economy by turning biosolids into a valuable product, biochar. So biochar is a chicken and egg situation in wherever you are. Now there is enough market, but we need to produce enough biochar to fill that market. Okay, that's it. Okay, that's it. Oh, thank you.
Thanks, Aravind. I was actually expecting you to show us a sample of biochar and do something with it, but okay, anyways, next time. No, thank you. Next, I'd like to call Alex Peel. He's the Senior Policy Officer for the Water Sector Emission Reduction and Climate Adaptation for the Victorian Department of Energy, Environment and Climate Action, DEECA. And in IWN, he's the Deputy Program Manager for Energy and Carbon, and also the champion at DEECA. So yeah, welcome.
Thank you. If I leave that there, can you still hear me? Is that okay? Yeah, there is. Okay, awesome. So thank you for having me here today. As Prith said, Alex Peel, and today I'm wearing one of a number of hats, but I'm in the Deputy Program position for IWN, Carbon and Energy. And I'm here deputizing for Stephen Reddington, who couldn't be here today, who does an absolute power of work in this program. So you start with me. So actually, no, sorry. Firstly, just talking about a bit of the context, I'm going to start with the bleeding obvious, that this program is about addressing our carbon emissions challenges, but also optimizing our processes so we use our energy better. But the key thing I just grabbed from this first slide is that working collectively in our shared understanding means we can have a massive, massive impact. And just one example here, which is a project that we've already done, just goes to show where we've come from. It's just 13 water corporations investment at the Kiamal solar farm. And that picture there is to scale. So it just goes to show the size of that solar farm is 2 or 3 times bigger than the CBD. So it's just one of the examples where when we work together, we can have this massive impact, and our investment is helping to put projects like that on the map. So that's a bit of where we've come from. But to talk a bit more about the challenge, the first challenge is that we actually produce a bucket load of greenhouse gases as an industry. A lot of people just do not realize that on the public, and a lot of people just don't really know the scale. Now, it's almost 1 million tons of greenhouse gas emissions, or CO2 equivalent, but I won't get into the detail. But just to try and kind of nest that for people, we're almost a quarter of the Victorian government's emissions. So that includes hospitals, trains, all the schools, public universities. So it's a big amount of things that the government does, and we are a quarter of that, which means we're almost 1% or 1% of Victoria's total emissions. So 1 in every 100 tons is from us directly. And that's just before we even get to the influence we can have on other sectors. So nesting that again, trying to make people understand what does it mean, and something that's a bit more tangible. Well, people know what cars are like and what they do. So it's about 250,000 cars on Victoria's roads. So bucket load of emissions, that's challenge number 1. And on the flip side, we've decided that we're going to be a world leader in this. So we have, as an industry, every water corporation is committed to being net zero by no later than 2035. So we're world leading with a big problem. And the third pillar of that is that the greenhouse gas emissions from wastewater treatment are one of the hardest things to actually deal with, on not just a Victorian scale, but a global scale. So they are biogenic, they're methanes, nitrous oxides, and the process of cleaning and treating that water simply results in these greenhouse gases. So it's hard to get them down to zero. So that's where we're at. It's a big, big challenge, and we've got to do it. Just that last point, we've got to balance our ambition with what we can realistically achieve in a reasonable time frame, alongside cost efficiency as well, because there's no blank check. You know, this isn't a blank check situation here. We have customers, we have cost pressures, so we need to look for opportunities. So that's where it comes a little bit to some examples, and just a few of many examples of the projects that we're working on. So the first one here, it doesn't sound like much, because we're talking about understanding the actual real life greenhouse gas emissions from our wastewater treatment plants. At the national scale, it's all just based on theory. You're given an equation, you put in the numbers, and it says, here's your estimate. But that doesn't give us any incentive to actually do real world process improvements. So as an industry here in Victoria, working with global partners, we're saying, well, how do we understand how those emissions actually change? Not just what happens on a yearly basis, but a daily basis, hourly basis. How do these emissions change when a temperature rises a degree or two in a day? So until we really get a handle of that at our treatment plants, which is a long-term problem, long-term challenge, that's when we're going to be able to actually say, well, here's how we address it at the source. Another example, positive disruption, and this is something that's happening down at Western Port, is saying, how can we challenge that traditional dichotomy of how we treat wastewater? It's putting in things like floating wetlands. You've probably heard of floating solar panels, but floating wetlands, where we're taking the natural process of dealing with these greenhouse gases and also other things like PFAS, and saying, how can we run this water through this floating wetland? How does that change how the greenhouse gases profile looks at that treatment plant? And there's some really good signs there that it actually helps. So it's trialing these different technologies. And the last one I just wanted to touch on is what I've just mentioned here as a symbiosis with emerging technology. What I basically mean is, what are those other opportunities there as our economy moves to low carbon? So the example I've picked out is hydrogen. So if you produce clean, green hydrogen, you need renewable power and you need water. So when you do that and you get that hydrogen, that results in oxygen. So there's a really good opportunity here for a wastewater treatment plant to say, I have excess recycled water, even though we've got so much water stress as a state, but I've got a whole load of recycled water. So there's a big opportunity for you, Mr. Hydrogen Producer, to take that, do what you need, generate the hydrogen, and we'll take the oxygen back and put it in our treatment process, make it more energy efficient, and also even, and this is what we're hoping to test through IWN, how does that impact on the nitrous oxide emissions as well? So there could be some real benefits here where you just kick multiple goals. And that's really what I wanted to leave it with in terms of impact. It's sort of a positive way to end on what is the globally very challenging thing here. But the Victorian water sector has decided to take on this challenge like in a full-throated way. And that means that we can be at the cutting edge and get ahead of these issues and really start to address and look for those partnership opportunities so that the water corporations can be at the forefront and ready for our low carbon transition. And I've just touched on a few there, but a couple of examples of what we can do, and there's a bucket load more. So if you're interested in this program in this space, it's a really, really interesting one, and there's a lot we can do. So thank you.
Thank you, Alex. I think I will say there was probably a lot there to unpack, and Alex is sitting right there. So if you want to have a chat to him after, please do. Now we are 5 minutes. Yeah, we've got some time for question and answers. Hopefully, answers. Are there any questions from the floor? Anybody want to ask to Alex, Aravind, or Callum? Oh.
So it caught my attention, the real nitrous oxide emissions. That kind of implies that we don't know what they are now, but does it also imply that they might be lower when we measure them than higher? Is that the implication?
Yeah, this works. So this is the challenge with a 5-minute presentation. You can't really delve into this stuff, but at the national level, under our emissions reporting requirements, you just take an equation and you input the different aspects to that, total dissolved nitrogen, etc., and it pumps out a number. But what you can find sometimes is that when you do that, and even if you change what you're doing in the real world, you might still get that same number, just because it's the theoretical equation stuff. So what we need to do in Victoria is get an understanding of how those emissions, what's the actual real world emissions profile, and it can be different at different treatment plants. So it requires a lot of trialing. So we're talking about trialing. Hopefully we can use some AI data to help us skip some of that. And then we can go and talk to, so firstly, that gives us actual incentive to say, well, how can we change this? How can we do it better? But we can also go and talk to the national regulator and say, the way you actually make us report this, we need a better way of doing that too. So it's it's a double-edged sword. Is that the right thing there? Double-edged sword, yeah, I'll go with that. So it allows us to both change the regulation proactively, but also change how we operate. So that's basically the crux of what that is there.
Thank you. Thanks, Alex. I had a question for Callum. With maintenance and operational expenditures, what do you think maximizing operational expenses is going to have on our aging infrastructure?
Well, I think it's not necessarily affecting our aging infrastructure, but it means we can spend more money on fixing it. So we like having a lot of things to fix. It's hard to prioritize where to spend the limited budget we have. But if we can improve how we spend our money operationally by adding in stuff that makes operations less time consuming, we can spend more time focusing on maintaining what we still have, which will in turn reduce what we need to spend money on. So it kind of reduces the pool of things we need to prioritise.
Okay, thanks. I'll open up to the floor again. Anyone else? If not, I have a question for Aravind. You did mention that the process doesn't completely remove heavy metals. I did make a note of this. What will happen to the heavy metals and other contaminants?
Good question, Prith. So what I mentioned was the heavy metal concentrations will increase. The total metals in the biochar will be higher than the total metals in the biosolids. Is simply a function matter of we reduce the volume of biochar to 1/3 from biosolids. Therefore, the total metal concentration will increase. But having said that, the bioavailable metal concentrations and the leachable metal concentrations will be lower, much lower. So yeah, but even though the total metal concentrations are higher, they are well below the C2 grade of Victorian limitations.
Thank you, Aravind. Do we have time for one more? One more. Okay, thanks.
One for you, Aravind. So obviously with PFAS, the pyrolysis process is meant to, I guess, evaporate it to a certain degree. But doesn't that just transfer the problem from one form to another? And has there been any progress made on, there's many thousands of PFAS compounds out there. What about the mass balance? Has that been considered?
Fantastic question. So we haven't gone that far yet. I think in our Pyroco Mark II, we'll do a comprehensive PFAS mass balance. But in general, there's no PFAS in the biochar, but the PFAS will end up in the gas stacks. And if you at that stage, we're going to burn the gases at 900 degrees centigrade for 2 seconds. That will destroy the PFAS.
Thank you. Thanks for the really engaging discussion. Just a quick one, Michael. Me and Callum, part of the asset management optimization group, we will be at a little desk outside. And what we're asking for is come and see us. We want to hear what do you want to see in the program in the future moving on. We'll be there waiting for your input. So thank you. And thanks to the panel.
Please thank the team. Thank you.